This video is over inventory management. I'm your professor, Dr. Stephen Haggard. So inventory is part of current assets, and net working capital is current assets minus current liabilities. So understanding inventory is important to understanding working capital management. So inventory is dynamic, which means constantly changing. And what that means is we have to be constantly vigilant or inventory can get out of control. And things that cause inventory to change would be both internal and external factors. So an internal factor might be a change to your process or a labor strike. External factors could be the economic condition or some sort of viral pandemic. All of these things can impact the level of inventories at our firms, and we must constantly be vigilant to make sure that we have enough inventory to do the job without so much that we are holding too much inventory. So what is inventory? Well, we say it's an idle stock of physical goods. Let's start with the word idle. Idle means it's not doing anything. You could have an asset that was productive and active, like a machine that you were using to produce products. That would not be idle. This inventory is basically just sitting around, and so we say it's an idle stock of physical goods. Note that we're talking about physical goods here. Think about the App Store, where we buy our apps on the iPhone or the Google Play Store on Android. You can buy things out there and you can get them immediately. Some people might say that they were in inventory, but they're not actually because they are not physical goods. Therefore, they would not be considered inventory. And it must have economic value. Economic value. In other words, this is something that we think will produce an economic benefit for the firm going into the future. And it's going to be held in various forms. And you can look through your operation from beginning to end and see inventory in different forms along the way. And once we get to the end, you'll see we also have inventory that we have ready to sell so we can meet customers' demands. So any organization that's involved in production, trading, sales, or service is going to have inventory. And what we're going to see is that inventory is considered a necessary evil. What do we mean by necessary evil? Well, it's something that we have to have in order to do business. Would we prefer not to have inventory? Absolutely. We do not like to have inventory, but we must have inventory in order to do business. And so what we turn to then is to try to hold the minimum amount of inventory necessary to achieve the goals we set for ourselves. So we've discussed these inventory essential characteristics in the previous slide, except for the last part. We mentioned that the inventoried resources have economic value and are considered to be assets of the organization. Now, this is the first time we've discussed that they are assets other than to identify them as current assets. And remember our definition of assets, and that is an item that has economic value that will provide economic benefit to the firm going into the future. And since inventory is hopefully going to sell within the next year, that makes it a current asset. So what are the different types of inventory you might encounter? First of all, there are raw materials. These are the things that your business buys to use in producing your finished goods. Raw materials could be plastic pellets, they could be wooden boards, they could be large ingots of iron. All sorts of things can be raw materials. And one person's raw material is another person's finished goods. I just mentioned iron ingots as a raw material, but those iron ingots would actually be a finished good for the iron facility that created those ingots. And then we have consumables. Consumables are things that don't necessarily wind up as an identifiable part of the finished good, yet they are consumed in the process. So a major example of this would be welding wire. If you use metal inert gas welding technique, or MIG, to join things together. We also call that wire welding, and it actually consumes a wire to join together the pieces of metal. Now, when it's all said and done, you can't identify that wire as one of the parts, and certainly you can't disassemble a thing and get the wire back in its previous state, and so that's considered a consumable. Another consumable with which I am familiar are the nozzles on a plasma cutting torch. Plasma basically is a state of matter where the electrons are stripped off of atoms, and apparently this makes them quite angry, and they basically just disintegrate whatever they pass through. And so if you can create this plasma beam close enough to a piece of steel, you can actually break the atomic bonds between the molecules of steel and cut out pieces of steel for further processing. During processing, though, the bronze nozzles that are used to form and direct this plasma beam get eroded away and must be replaced on a regular basis. Therefore, though they are not part of the finished product, they do get consumed in the production process. They are also considered consumables. And the final example that I'll throw out here is a relatively recent one, and that would be the use of adhesives in automobiles. You may find it strange to learn that adhesives or glues can be stronger and weigh less than an equivalent weld. And so today's automobiles, one of the reasons they're so quiet and so solid is because they contain a lot of adhesive. But if we tore that car down, we could not get that adhesive back. Therefore, that adhesive is considered a consumable. And then we have work in process, or WIP. WIP would be something that we've started putting processing into. We've done some work to the raw material. We've added some value, but we are not yet to the finished goods stage. And you may also hear these referred to as semi-finished goods. Then we have finished goods. These are ones that are available for sale to the customer, and they may be stocked at the plant. In other words, they come right off the end of the line, and before they get shipped out, there is a buildup of finished goods there at the factory. You may find them in a warehouse where we would store these items awaiting further distribution to distribution centers. Distribution centers have become a very big thing since the advent of e-commerce because the sellers no longer have to have physical locations. They can have their things located at different distribution centers around the country, and they don't have to be necessarily in high-dollar retail areas. And so you'll see these distribution centers popping up outside of larger cities. Amazon, in particular, is good at building distribution centers. But brick-and-mortar stores also have these distribution centers. For example, Walmart. Walmart probably has a distribution center within 100 miles of your location. And then finally, we have any inventory in transit to which the firm holds title. And this is where we get into the idea of FOB, or free on board. Let's say that you are a producer of airplanes in Seattle, Washington, but you buy your aluminum from a company in Chicago. When they ship that aluminum, if it is FOB Chicago, that means as soon as it ships, that inventory becomes you, the plane builder's, responsibility. If there is a train wreck or a truck crash along the way, you're responsible for that inventory, and that inventory is actually already on your books. However, if the shipment was made FOB Seattle, the manufacturer of the aluminum would be responsible for it all the way up to your dock. And so if something bad happened along the way, they would be responsible for that inventory, and the inventory would be on their books, not yours. So why do companies hold raw material in inventory? Well, it's so we can handle variations in production demand. So this is reason number one. What if we have highly volatile demand? Well, we could approach that from a couple of different ways. Number one, we could create the finished goods and hold them until we needed them for sale when the variation went upward on the demand. However, that's going to have a lot of value associated with it, and so a higher cost of carrying it. It's cheaper to hold the raw material inventory. Now, why would I buy the raw material in advance and stock it up for such an occasion? Maybe my supplier can only produce so much raw material at a time, and it's better for me to stockpile it than to try to buy it when the time comes. Examples of this might be rare earth metals or cobalt, things that are used in the production of smartphones and batteries. Then we also need to cater to cyclical or seasonal demand. If you've ever worked in retail in the United States, you know that the fourth quarter is the biggest quarter of the entire year. And we start actually building up that inventory between July and September. And so the manufacturing of that is going to have to happen March through June, and that means that we're going to have higher raw materials in January through February timeframe. And so that's one of the reasons that you'll see raw material inventory being held, is to cater to these changes in demand. You can see a similar situation in China. Right before Chinese New Year, we build up a lot of raw material inventory. We build up a lot of inventory period to get us through that time period of a few weeks when nobody does anything in China. And then there's economies of scale in procurement, and particularly here we are talking about ordering costs. An ordering cost would be a fixed cost per order that we incur when we place an order. And so if we do fewer, bigger orders, our ordering costs overall will be lower. And so it might make sense to go ahead and buy more at a time and make fewer orders per year. And then there are expected price increases and quantity discounts. So I remember working in the plastics industry, and we would get excited phone calls from the people who sold us our plastic resin. And they would say, "Oh, did you see what's going on with oil prices?" And the answer was, at the time, they were going up. We said, "Yes." And they said, "Well, you know that plastic prices always rise after oil prices rise. So you should probably go ahead and order your raw material ahead so you can get it now for the cheaper price." I always thought this was kind of interesting, because after all, salespeople work on commission and they get the same percentage. It would behoove them to wait and sell it to you at the higher price. But their lack of patience and probably some bills they had coming due pushed them to try to sell more sooner rather than waiting for later when their commission would be larger. And then there are quantity discounts. Once again, when I worked in the plastics industry, the company that I worked for was a small operation, and we bought our materials in 25 kilogram bags. 25 kilograms is about 55 pounds. And then our competitor across town, they were huge, and they were buying these things by the rail carload, 40,000 pounds at a time. Who do you think got their plastic for the lowest price per pound? Of course our competitor did, because they were able to buy such huge quantities. There was no packaging costs, and certainly it cost less to transport a rail car full of resin than to transport a truckload full of bagged resin. Then we've got the issue of transit costs, which I just discussed briefly. But let's talk about the idea of LTL. LTL means less than load. If you can fill an entire 53-foot trailer by yourself with an order, then you can totally control the timing of that truck. However, if you are going through someone called an LTL carrier, basically what they have at these LTL hubs are areas drawn out on the floor the size of a trailer truck, and they start parking pallets in those outlines waiting until they get enough to make up a truck. And once they do, they put all the stuff on the truck and then they make the run. And so if you are lucky enough to be the last pallet on, then you can get your stuff fairly quickly. However, what if the truck just left when the pallet of raw material shows up for you? It's going to have to sit there for quite some time while more stuff comes in order to fill out that truck. Additionally, on a per pound basis, less than load shipping is more expensive than if you were to get a full trailer. And so for these reasons, you might want to just go ahead and buy a full load of whatever your raw material is, so your transit costs will be lower, and so you'll get it in a shorter time with greater certainty. And then finally, we have long lead time, high demand materials. There's a certain pigment, and you're probably familiar with it. If you've ever driven out on the highway at night and you notice why those signs reflect so well, or if you've ever noticed the highway workers' high visibility vests with the reflective strips, the stuff that makes those so reflective is a very special pigment that gets manufactured in Germany once per year. And it's done on a laboratory scale setup. In other words, they don't have a factory. And so two guys basically set up a benchtop apparatus to create this very rare, very expensive pigment once per year. If you do not order your pigment at that time, you have to wait an entire year to get your hands on it unless you can buy it from someone else. And so this stuff would come in a jar about 1 liter large, and it would cost us around $30,000. As a result, we would buy that, and then we didn't keep it in our normal warehouse. We kept it in a safe in the CEO's office, and whenever we needed to use it in production, we would send someone up to fetch the bottle. We would bring it down and very carefully weigh out the tiny amount that we needed, and then we would send it back to the CEO's office for safekeeping. So let's talk about why and when firms hold finished goods inventories. Well, first of all, you've got market size, location, and the supply chain design. Let's talk about Apple. Apple is really big in the United States, which is a big market for its product. It's also very big in China, which is another big market for its products. Most of those products, though, are made in China. If Apple wants to be able to sell quickly to someone in the United States, then they need to have finished goods inventory staged in our market. And the same would be true of Europe and India and other places like that. They need to have inventory staged and ready to be shipped to the local customers. And the location may matter. So for example, in China, where it can be shipped straight from the factory and within 1 or 2 days be exactly where it needs to be, they might not hold as much finished goods inventory since they can ship directly off the line. And then supply chain design also has some things to do with it. So I have noticed when I buy something from Apple, like a new iPhone, if I order it on the first day it's available, then it always ships to me directly from Shenzhen, China, and arrives via FedEx. That would mean it's going through air freight. In fact, I watch it as it comes through, and it stops in Anchorage, Alaska, where it always sits for entirely too long. Now, what about if you order something that has been out for a while and you're just ordering the standard configuration? Then Apple has an entirely different supply chain for that. That's where they have the local market finished goods warehouse that they are able to ship from. And so differences in supply chain can determine where you store your finished goods inventory. I have one more example on this. It's a Chinese manufacturer of webcams, actually not webcams, security cameras called Foscam. And when I first started doing business with Foscam, they shipped directly out of China. But as time went on and the U.S. surveillance video camera market grew, They actually built a warehouse in Houston, and now they hold a large stock of finished goods there to be shipped out within 2 days to anywhere in the United States. And so they've changed their supply chain design as a result of the growth of the U.S. market. And then we have build to stock versus build to order. If I'm building something to stock, it means that I am building something without a firm order for it. And most likely, I'm going to create it in a manner that will appeal to the most customers. One example would be the cars you see on the car lot. Those cars are not put together in some random fashion. They are ordered with the options that the manufacturer thinks will be most likely to get people interested in buying the car. Now, they build those without a firm order. However, I'm very picky when I order cars, and so I always build to order. In other words, I put in an order for exactly what I want, and then I wait, and I wait, and I wait. For my last 3 vehicles, I've ordered them and then waited about 3 months before I got them. But that means that the supply chain's different. For the build to stock, they are storing the finished goods near me. But for the build to order, these cars are coming out of either Germany or England. And so the finished goods would last be in the company's hands over there. Then we have marketing campaigns. If you're about to go out and do a marketing campaign and you think that there's going to be a lot of interest in your product as a result, which by the way is the purpose of a marketing campaign, then it makes sense that you need to build up inventory beforehand in order to be able to handle that increased demand. And so if you were doing a marketing promotion in Panama for your product, then you would store some finished goods in Panama in order to be able to handle that increased demand. Then there are local taxes and other government rules. You might notice that many foreign automakers, Tesla is the first one to step away from this model, but many foreign automakers who do business in China are partnered with a local Chinese company, and they are able to build vehicles in China. And it turns out that a vehicle built elsewhere is going to cost you about 50% more when you buy it in China than if it is manufactured locally. That's because of the tariffs that the Chinese government places on incoming foreign automobiles. But if you make those in the country, then you don't face those taxes. And as a result, you see all of the major automakers having factories in China. That's exactly why Tesla built their factory in China. And then occasionally you'll have strange little rules, like the law in New Jersey that requires any liquor being sold online to any address in New Jersey be shipped from a warehouse in New Jersey. And so you might not want to actually have any sort of business arrangements in New Jersey other than shipping there, but this law would require that you have a warehouse there. Now, if the surrounding states didn't have such a requirement, you might choose to put your finished goods in New Jersey, even though it might be slightly cheaper to put them in another state, simply because then you would not be able to service New Jersey. And then we have production lead times. If something takes a long time to manufacture, then we need to have higher finished goods inventory for that so we can meet customer demands. For example, right now, whatever the next iPhone is, they are undoubtedly already producing it, even though it won't be introduced until later. They are building up that finished goods inventory because undoubtedly when they start selling those, they are going to sell much faster than Apple can produce them. And then we see people holding finished goods inventories for speculative gains. What is speculation? That's when we're basically gambling on the value of something going up. For instance, if you thought the price of oil was going to go up, you might buy and hold oil. And you can do the same things with your finished goods inventories. If you think that your supply of webcams or hand sanitizer or toilet paper is going to be more valuable in the future, then you might hold on to it, thus holding a larger inventory of finished goods than you normally would. And when prices go up, then you go ahead and sell and take advantage of those speculative gains. We actually have a company in Springfield called SRC, and they have many different divisions doing many different things, but one of their divisions actually goes out and buys up scrap metal and then holds it in speculation of a price rise on the metal. And they've been doing this consistently profitably for quite some time, so it lets me know that it's actually possible to do that. And then finally, we have avoiding costs. We've already talked about ordering costs, so let's focus on stock out costs. A stock out cost is the cost incurred by not having a product available when your customer wants it. If you don't have it available, then you can't sell it, and if you can't sell it, then you don't get the profit. Furthermore, there are some intangible stock out costs. For example, if I go to Walmart 3 times in a row and they still don't have what I need, but Target does, I might stop shopping at Walmart altogether. So too much inventory can be a sign of problems. First of all, supplier inefficiencies or unreliability. If you go through my house on any given day, you'll see that my wife and I carry a larger inventory of some items than others. And that is, we buy things that we like, but we often find out of stock on the shelf. So what does that incentivize us to do? When we do see it on the shelf, we basically buy all the stuff off the shelf that we can if it's not a perishable item. And so we end up carrying more inventory simply because our supplier, in this case Walmart, is unreliable. And then there can be bad quality. If you make an item and it's not quite right, but it can be fixed, you're going to have to send it through a process called rework. And during the time frame that it is awaiting rework, it is still in your inventory. And so you can actually have too much inventory simply because of all the dysfunctional items that you've produced. And then we can have increased production and inventory due to rejects. Anytime Apple introduces a new iPhone, there's always the beginning, and people will report how many screens Apple is ordering for these phones, and we use this as an indicator of how many phones Apple is creating, which is an indicator of what Apple thinks the market is going to be for their phones. And then after 2 or 3 months, you always see a headline, Apple cuts screen purchases in half. The inventory or the demand for this new iPhone must not be as high as they expected. That's not true. Here's what's really going on. When you start making a new screen in the beginning, only about half of them work correctly. And sometimes that half that's bad can't be found until it's actually plugged into the phone and tested for the first time. As a result, what Apple does is buys twice as many screens as they need in the beginning. But as the production process gets smoothed out over the life of the production of that screen, then we will see fewer and fewer rejects, and so Apple doesn't have to carry as many of those screens in their inventory. And then we've got production delays. So the first one we'll talk about is bad design. And I used to actually be a design engineer. And one of the products that I worked on was a subsurface safety valve for oil wells, basically to prevent oil from escaping if there's an accident. And the particular valve that I'm thinking of had 22 parts. And these 22 parts were rather complex, and they took a long time to build. We redesigned the valve to only have 10 parts, and we did as much as we could to simplify the production of the valves. And what that allowed us to do was to produce these more quickly, less expensively, and as a result, we were able to have less inventory on the shelf of those valves and still meet our customers' demands. And then there's inefficient plant layout. Remember, any time that you have goods moving between workstations, the longer that trip is, the more inventory it's going to take to fill that pipeline to keep those machines running. And so you may see a really inefficient layout of a plant, which there are many, leading to excesses in inventory. And then there are breakdowns. I had this machine. It was a Nagata horizontal mill. That's actually a milling center. It was machine number 464. And that thing broke down all the time. I would always come in first thing in the morning, before the sun even comes up, and go immediately to machine 464 to make sure it was running. And sometimes I could tell before I even passed through the door that the machine was broken down. How could I tell? Because of the stack of jobs that were sitting at the machine ready to run on it. I knew that the machine was not running or the stack would not be that big. And so breakdowns can lead to having higher inventory and lengthy process times. The same machine, the 464, would take up to 7 hours to drill a single long hole, something called a gun drill. Well, if I could just turn around those things and make that happen very quickly, I would have that inventory in my pipeline for less time, and therefore my overall inventory would be lower. We also were cutting high nickel alloys like Inconel, and those took a long time to cut. And then we brought in some people who taught us a new way to cut that, and we were able to cut the processing time by 2/3. That was quite helpful because it was a long processing time. The longer the processing time, the longer that item was in my inventory, and Inconel is very expensive. And so it was really great to be able to get that out of the door perhaps one day sooner than I would have otherwise, so I could get it out of my inventory. So let's talk about the dangers of holding too much inventory. First of all, it ties up working capital. If I've got cash, I would much rather put that cash to productive uses rather than using it to put inventory on my shelf. And so if I would have less inventory, I could have lower working capital, and I could put that money to more productive uses. Then we have to worry about spoilage. Products go out of date if there's an expiration date on them. You might not even realize this, but even tires have an expiration date on them. And so if you go out and buy cheap tires on eBay and they say brand new, they may have never been on a car, but they're past their freshness date and would not be safe for you to drive on them. And if I've got too much inventory and I don't rotate it properly, it's probable that some of my inventory will go out of date. And we also have problems with products that corrode or decay. I used to work on items that were made out of carbon steel. And carbon steel has a tendency to rust if it's not properly protected. The way that we protected it was to put a coat of oil on it. But after years on the shelf, that oil would evaporate basically, and we would end up with rusty parts. And then the client calls for a part and we show one in the system, and when we send the person to go pull that item off the shelf, we find that it's rusty and we cannot send it to the customer in that condition. And so now we have to either rework that part to remove the rust, or we have to remake that part. Either way, it's going to put us behind and cost us additional money. And then we used lots of what we called elastomers. These are O-rings that are used as seals. And these elastomers, just kind of like a rubber band, as they get older, they don't work as well. And so eventually they'll pass their freshness date and you'll no longer be able to sell them to the customers. And then we have theft. People are scumbags. And that means that theft is going to be a problem basically anywhere you go. And the more useful the item is to someone, or the more saleable it is on eBay or Amazon or similar, then you'll see more theft. For example, the nightmare scenario would be the sneaker warehouse. If you have athletic shoes in a warehouse, your workers, first of all, would like a pair for themselves. And after all, they see thousands and thousands, and they don't think that one pair will go noticed if it just goes missing. And so you may pretty soon notice that all of your employees magically have new shoes that look just like the ones you're selling. Thinking back to the example that I gave of the expensive pigment, we kept that locked up. Now, it would be difficult for someone to sell that, but they would probably be stupid enough to steal it and try. And once they figure out that they can't sell it, then they would probably not want to return it because it would expose them to being caught. And so you see theft of things even that people cannot use. And then finally there's obsolescence. When something is obsolete, it means that it works just fine, but it's not the latest technology. For example, back in 2008, I bought an iPhone 3G. And that iPhone 3G was just lovely and it worked just fine for what I needed it for. However, when the iPhone 4 came out, suddenly that iPhone 3G was obsolete. And as a result, no one wanted to buy the iPhone 3G. In fact, to this day, you can still buy iPhone 3GSs, I think, new in the box, and for cheap. Why are they cheap? Because of obsolescence. Should Apple have kept less finished goods inventory of the iPhone 3GS? Absolutely they should have, because certainly they're losing money on every one of those things that goes out brand factory new. So let's talk about different types of inventory demand. First of all, there's dependent demand, and that is when the demand for an item depends on the demand for another item. For example, whenever I order my car, that's independent demand, but that independent demand then creates dependent demand. There needs to be 4 tires, there needs to be an engine block, there needs to be 6 pistons, there needs to be all sorts of parts that are created to meet that independent demand. All those parts would be dependent demand. And many of these things are assemblies, and they would further create additional dependent demand. Independent demand is demand that doesn't depend on the demand for another item. And so, for instance, we have finished goods like the car. However, some things have both demand and independent demand. For example, spare parts. So, spare parts are good for building new cars. That would be dependent demand, but they're also good for replacing broken parts. That would be independent demand. In fact, a friend of mine sells tires, and he is really into what goes on in the tire industry. And he says that they have an issue where when new car sales go down, then the tires that were going to the new car plants as dependent demand are now sent out to meet independent demand. And so you'll see, even though that there is a drop in the production, there are still plenty of tires available for people at large because that dependent demand tire is now being sent to your local tire dealer. So how do we manage independent demand? Well, first of all, the sales order process. If we are building to order, simple. We wait till we get an order and then we go ahead and use that information to pull through all the other orders, the dependent demand parts, and schedule those out for production. However, what if you're building for stock? Then you need to work to your sales forecast. Now, I can't tell you much about any forecast except for the fact that it's most likely wrong. And so now here we are building things based on a forecast that we know is flawed. Either we are going to have too much inventory and have things perhaps go obsolete on the shelf, or it might go the other way and we would have a stock out and not be able to meet all of the demand for our products. Dependent demand is managed through an MRP ERP system, or through something called Kanban, which I'll discuss here shortly. Let's talk about what MRP ERP means. MRP is Manufacturing Resources Planning, or Materials Resources Planning. And you can tell that it's really based in the idea of manufacturing facility. But we have now things other than manufacturing that need to do planning for resources, and so now we have ERP, Enterprise Resource Planning. And in addition to pulling these dependent demand items through based on the independent demand, these systems also plan for human resources and things like that. So they have extra add-on modules. But at the core, there's always going to be an MRP inside of these ERPs. And so what happens? When the customer places their order, then the MRP system looks at that and breaks it down to its components. If some of those parts take 60 days and go directly into the final assembly, then those will get built first. Parts that take only 30 days to get built will get started 30 days later. And so in this way, we are able to minimize the inventory. We don't finish a part and then just have it sitting around for 60 days. The ideal is to have everything show up just exactly when it is needed, because that minimizes the amount of inventory that we hold. Now let's talk about Kanban. Kanban is a Japanese word, and it literally means signboard or billboard. And in fact, my wife and I actually use a Kanban to remind us when it's time to put out the garbage, or if we pack a lunch for work, we always put out the lunch Kanban to remind us to take our lunch with us to work. Now, Kanban, very useful. In fact, let's take a look at this. You can tell that says it's from Hattiesburg, Mississippi. We haven't lived in Hattiesburg, Mississippi since 2007, and we still have this same Kanban card. So obviously it's meaningful to us, or we wouldn't still be using it. I know this seems all a little bit strange right now, but what you need to understand about my wife and I is that she came out of industrial operations management, and I came out of manufacturing, and we both knew about Kanban from our work. So what is Kanban? Kanban is a system that uses the demand of the final finished good to pull products through the production line. So let's start over on the right-hand side with distribution. You can see each one of those little boxes has a Kanban card tacked to the side. And when one of our warehouse people pulls a box to send out, they remove the Kanban card and they send it back to the manufacturing area. And that manufacturing area has a row of these little pockets, and we start filling these, put these Kanban cards in there, and once they reach this level here, then it triggers production of an order. And we would do an optimal order size, which we'll talk about here in a minute. And so that's going to trigger an order, and they're going to go through manufacturing, and in the case of the work that I did, those Kanban cards would actually be stuck in the work packet with the paperwork for the order, and when they finally got packaged up, the packaging people would take those Kanban cards and stick them to the side of the items and put them in our finished goods inventory area ready for shipping. And so in this way, we are only producing things as they get consumed. That's why this is called a pull system. We are using the demand to pull things through our manufacturing. Sales forecast, on the other hand, is a push system. And with a push system, you run into the dangers we talked about earlier, which is under or over producing. So let's talk about inventory costs. First of all, there are ordering costs. And let's talk first about the inbound logistics costs. We discussed these a little bit with the truckload versus less than load versus train, but there are definitely costs associated with getting things onto your shelf, and those all go into the cost of your inventory. The other ordering costs that we talk about are the costs of procurement. And I'm going to advise you to be a little cautious when you hear about this. So I worked at an organization and they said, every time we order something, it costs us $17 or something like that. And I said, really, how did you come up with that number? They said, well, we took the procurement lady's salary and divided it by the number of orders, and that gave us our $17. Now, the mistake in this thinking is, if I make one less order, am I going to save $17? No, we're still paying this person the same amount we always were. And so these costs of procurement can be a bit squishy, so be careful when you hear people talking about that. Anytime people say they're going to save these costs of procurement, ask who in procurement are you going to fire as a result of ordering these fewer items, because that's the only way we're going to save that money. And then there are carrying costs. We have our inventory storage costs, and you may say, well, that's warehouse rental, but it's probably more than that. We have to have security, and we also, for instance, have to have climate control for some items. My father worked in a dynamite plant for many, many years, and all of the buildings and warehouses were air conditioned, not for the comfort of the employees, but to maintain the freshness of the dynamite. And then there's our cost of capital, the money that we are using to put this inventory on the shelf comes from somewhere. And our firm has a weighted average cost of capital. And so you could assume that's the cost that it's taking for you to put inventory on your shelf. And then there's the possibility of shortage or stock out costs. And we've talked about these a little bit. First of all, there's lost sales. We've discussed that. But then there are expediting charges on replacement items. I'll give you a couple examples here. When I was in high school, I worked in a grocery store. And when we ran out of milk on the weekends, we could order an extra load called a hot shot. And the hot shot would show up on a smaller truck, and they would offload all of that milk and then send us a bill. And I guarantee you we paid more per gallon for that milk than we would have if we had got it on the regular delivery. And when I worked in the oil field, we also had hot shots. If a rig offshore needed something in a hurry, I could sell them that same item for 3 times as much and use part of that money to cover the cost of driving that one particular part all the way from Dallas, Texas to the Gulf of Mexico or to the airport to be sent to the Middle East. Those are expensive expediting charges, and so if we can avoid the shortages that lead to them, we will be better off. Now let's talk about outsourcing inventory. Inventory might not be your core competence. In fact, you might be pretty bad at it. And so it might make sense for you to outsource inventory to another firm. You might consider the idea of field warehousing. That's where someone else has your items in their warehouse and ships them out for you. And they make sure that your inventory doesn't get stolen or burned or damaged. In fact, you can think of Amazon as an inventory outsourcing company. Many of the vendors on Amazon don't want to run their own warehouse. Instead, they send their items to Amazon's fulfillment centers, and Amazon manages that inventory for them. And so it frees you from doing a lot of things. For instance, building and managing a warehouse, and that could free resources for other functions. For example, that money that you had tied up in your warehousing function, now you might be able to do additional research and development to make a better product. There is a downside though. Outsourcing your inventory might increase your costs, and it definitely reduces your control of your inventory. I always enjoyed being able to walk immediately back to the warehouse and make sure that I actually had something before I promised it to the customer. If you are outsourcing your inventory, you can't do that. So recently, my wife and I tried to buy a dishwasher, and it wasn't available at our Lowe's. And so we headed south 20 miles to the next town to their Lowe's because the system said it was in stock. But when the lady went back to put her hands on it, she couldn't find it. It wasn't there. And so this is the kind of danger that you run into when you have to get your inventory somewhere else. You can't just lay your hands on it. So let's talk about how we control inventory. So inventory, we know, has economic value, and therefore it's an asset of the firm. And we need to keep a close eye on it to make sure that it is sticking around and doing what we need it to do. First of all, we need to manage it to make sure that there's a proper environment. Think back to the dynamite example. We need to make sure that our proper environment that is there so the product doesn't degrade. And we also need to protect theft or damage to the product. I used to work in an oil field camp in New Iberia, Louisiana. And the people that I worked with were lovely people, but they were also very trusting people. And they would leave the gate to the warehouse unlocked when we went to lunch. And people would come in, and they weren't necessarily stealing items, but if there was no one around to properly check out an item, they would just grab it off the shelf and go do whatever job they needed to do with it. And as a result, when the time came and we needed to ship something out or send something to a rig site, we would figure out that even though it was on the system, we did not have it on the shelf. And they constantly complained about this until one day I said, guys, have you ever thought about just locking the gate to the warehouse? And so we did. And it was amazing how much more accurate our inventory was after that. So inventory exists in basically two ways. It's in a physical sense, what you can see on the shelves, and also what is in the books. And in the best of all outcomes, those two would match exactly. And the way that we're going to try to keep them in line are through things called audits and cycle counts. Let's start with the cycle count. This is just a sampling check of items in physical locations. And when we talk about sampling, it's less than 100% for our daily cycle count. I used to work for a truck suspension manufacturer, and our inventory manager, every day, the computer would produce a list of 12 items and tell us, basically create a little sheet for the warehouseman to fill in. Now, you don't want to put the number on there that we think we have, because the warehouseman will just copy those numbers off and then go smoke a cigarette before coming back to tell you that everything's there. And so only the warehouse manager has the numbers that the computer has spit out for what should be on the shelf. The warehouse worker has the sheet with the blanks, and they go out and count. And when it comes back, then we do a reconciliation of those two. And hopefully they match, but if they don't, then we investigate and try to fix the problem or find what led to this issue so we can fix the cause. We also can do quarterly and half-year cycle counts and wall-to-wall cycle counts. These are all 100%. Now, in order for these to be done, what we need to do is actually freeze transactions into and out of inventory. Because if we don't, what's going to happen is someone will count something and then we will remove it, and then we will deduct it from the system, and things will be not matched. And so we basically have to shut things down while we do this count. It may be troublesome, but it definitely leads to a more accurate count. So let's talk about the inventory audit process. That's where we do this freezing that we're talking about, and we do our 100% count during a freeze. And that keeps us from having errors in our counting, as we discussed earlier. So let's talk about why your counts might be off. First of all, someone might have stolen something. If you're short, someone might have stolen it. They might have removed it from the shelf and shipped it out without doing the proper transaction. They might have shipped out 13 when the order only called for 12 and they did the system transaction for 12. We might also have, people damage inventory all the time. And it is the nature of scumbag humanity to try to hide when something like that happens. So what do people do? Well, they throw it into the trash bin and hope nobody sees it. Well, that's going to cause us to be short on our inventory on the back side. Now we also have a problem where we could have too much inventory. That's potentially even a bigger problem, and we'll get to why that is shortly. Some of the causes for that could be that people have put stuff into the warehouse without properly doing the transaction to put it in. We might have also had a supplier ship us too much but only charge us for the correct amount, and so we would wind up with extra stuff on the shelf. But the most dangerous by far would be where we have created an assembly that's missing a part. Think about airbags in cars. Think about your own car. Take a look at the steering wheel and ask yourself, do I know if there's actually an airbag behind that cover? In truth, you don't. In fact, airbags could get left out during production and no one would notice until we do the inventory audit process, in which case we will find that we are long on airbags. And after we eliminate every other possibility, we come to the conclusion that we've left an airbag out of a car. Now, if you are the typical scumbag manager, you will just hope that nothing happens and that car lives a full and happy life and that airbag never has the opportunity to be used. But I can tell you from my experiences with so-called randomness that car is the most likely one to be involved in a head-on collision. And so what do you have to do? You have to recall every single car made since the last time we had a clean audit of that part number. And so if it was 3 months worth of production, we've got to recall 3 months worth of cars and inspect them all for airbags. Now, what does that mean? It means that there might be some wisdom in auditing some of these critical parts more frequently, because if you were doing it once per month, you would only have to go back and recall 1 month's worth of vehicles instead of 3. So let's talk about inventory planning and some very basic concepts. The first one we'll talk about is the economic order quantity. That's a model that's going to determine our optimal order quantity that's going to minimize total inventory costs. And we'll see in a minute what cost that's trading off. And then there are 2 kinds of ordering models that we might consider. One is the continuous order model, and that is where we order a fixed order quantity whenever the inventory reaches a certain predetermined safety level. And keep in mind that we have to have a predetermined safety level on inventory because even after we place the order, there's going to be some time that goes by before we actually get the product. And the longer the lead time is, the greater the safety level needs to be, because we don't want to run out while we are waiting on that order. So that's the continuous order model. And then there's the periodic system model. And that's where orders are placed for the amount needed after a fixed period of time. My wife and I go through our cabinets every Saturday, and we put together a list of the things that we need. And then we go shopping once per week and try to get our hands on that stuff. That is a periodic system model. Also, the model that grocery stores use to order is a periodic system model. They go through, and in fact now robots are taking over this job, but when I was in that job, you went visually and examined the shelves, and you entered in the numbers into a little computer for the items that needed to be ordered. And so that's how we received our grocery shipments twice per week, was based on this periodic system model. Now let's talk about the economical order quantity. It's balancing carrying costs, those are the costs of having this stuff on your shelf, against the ordering costs. Because after all, if there were no carrying costs, we would just want to make one big order once per year. And if there were no ordering costs, we would want to just order one item as frequently as possible to keep our inventory at its absolute lowest. What the EOQ is doing is balancing out those two costs. So what are the EOQ assumptions? First of all, it assumes no safety stocks. That's a bad idea. Secondly, it says no shortages allowed on deliveries. I'm going to tell you that's a bad idea too. If you're doing production and you've got 300 airbags ordered for the cars that are coming in, and they only send you 298, do you send the 298 back? I don't think so, because you want to keep your production line running. So that's another kind of bad assumption. Here's another bad assumption. Demand is uniform. I've never heard of uniform demand for anything, even things that you think might be relatively uniform, like gasoline or electricity or even water. It's interesting my wife and I, of course, are business professors, and we go in and sit in restaurants, and we're very predictable. We go to the same restaurant on the same day at the same time. And we are always, so it's like Wednesday at a certain time, we're always there. And we are amazed at the volatility in demand. And so it's very strange that we would assume that demand is uniform. And they're also assuming the lead time for the order delivery is constant. The only way you actually get true lead times is to call them and ask them, if I order this today, what is the lead time? Because it could change tomorrow. And it doesn't consider stock out costs. And we know stock out costs are real. Now, you may be thinking that makes EOQ a total piece of garbage. Not really. A lot of these assumptions, if we relax the assumptions, maybe we're not impacting ourselves that much on the EOQ. And more clearly, I think we should just think of EOQ as a starting point, and then we fine-tune from there. My planner, when I was at Halliburton, was a man named Bill Edwards. And Bill Edwards, when we would start doing something new, he would start out with EOQ. But then he would adjust as time went on based on our experiences. And he was really good at doing this, and I was very pleased to have him work for me, because my inventory turns were always quite good because he managed these things so well. So how do we figure the economic order quantity? Well, it's the square root, that's what that funny symbol means, of 2 times the annual demand times the ordering cost divided by the carrying costs. So the higher the demand, the higher the EOQ will be. The higher the ordering costs, the higher the EOQ will be. And the higher the carrying costs, the lower the EOQ will be. And when we plot this out, we can see that here is our annual ordering cost as our order quantity goes up, and it is a curve coming down. So it's like going 1/2, 1/3, 1/4, 1/5, 1/6, and so forth, because we are spreading out the same cost over more and more items. But that annual carrying cost is directly proportional to the order quantity. And so it's a linear relationship. If I add these two things together, I get the blue curve. And this bottom part here, that is the minimum total annual cost. Now I want to point something out to you here. If we go over here, we haven't really increased our costs that much. And if we were to come over here, we haven't really increased our costs that much. My point to you is this. EOQ, due to the assumptions that we make, will not be perfect. But it doesn't have to be perfect because there is some room for error here. So here is our EOQ example. Our raw material costs $22.50 per ton. Forecasted consumption is 5.75 million tons per year. And our annual carrying cost is 40% of the acquisition cost, and our ordering cost is $595. And so we can look at the variables in our formula and know that D is equal to 5,750,000, S is 595, and that carrying cost, which is also per ton, is 0.4 times 2250, or 9. And so when we plug all that in and take the square root, we see that our economic order quantity is 27,573.135 tons per order. And so in theory, what we would do is order that much every time our inventory reaches the critical level, that would be that safety level, in the continuous order model. Now let's ask this question. Do you think anyone's actually going to sell you 27,573.135 tons? No, more likely you're going to order 25,000 tons or 30,000 tons. And so you're going to have to use your judgment as which way to go. So we have a lot of great references here. And these were all written by a man in India. And my Indian friends use this amazing Victorian English. And it's very recognizable to any Victorian Englishman, but for Americans, it's a little more difficult. And so I would advise you, if you're going to read these articles, then just be a little bit patient because this person has gone to a good time and trouble to put these together for you. And definitely you can be a little patient when you are reading their English.